Now I am going to explain the rational numbers. Now, what is a natural number? The number which are used to count the objects are called natural numbers. In natural number, the word, what is the first letter? N. So that's why the natural number represented by the letter N. So the counting numbers are 1, 2, 3, 4, so on. What is the least natural number? The least natural number is 1. The largest natural number we can't say. Suppose number of stars in the sky. Number of stars we cannot count. Many stars are there. Like that, in natural numbers are we cannot count. Infinite numbers are there. Now, what about zero? Zero is invented by Aryabhatta, great mathematician. So now the zero along with the natural numbers, the set is called a whole number set. In the whole number set, what is the first letter? W. That's why whole numbers represented by W. Next, what other numbers? We can create the negative numbers. For example, I am taking east, west, north, south. Here we can say that opposite words are there. Here, what is the opposite of east? West. Opposite of west, east. The opposite of north, south. The opposite of south is north. Like that, we can create the numbers also. The opposite of 1, minus 1. Opposite of 2, minus 2. Opposite of 3, minus 3. Like that, along with 0, we can create the integers. Okay? Can you say the least negative integer? We can't say the least negative integer. But largest negative integer is minus 1. And what about 0? 0 is neither positive nor negative. And also we can't say the largest positive integer. And how to represent the integers? Integers represented by Z. Z means what? German numbers is the German word. That's why the integers represented by Z. Next, what other numbers? The numbers which are in the form of P by Q. The numbers which are in the form of P by Q. For example, take 2 by 3. 2 by 3 in the form of P by Q. Like that. So, the numbers which are in the form of P by Q are called rational numbers. Why it is called a rational numbers? For example, 2 by 3, how can I write? 2 is to 3. And suppose 5 by 6, how can you write? 5 is to 6. Okay, these are the ratios. That's why these numbers are called rational numbers. Why represented by Q? Why represented by Q? For example, I am taking 16. 16 divided by 2, how much? Yes, 16 is the dividend. Dividend divided by divisor, we got the quotient. And one more example, 25 by 5 equal to how much? 5 5 is 25. Here, 25 is the dividend, divided by divisor, we got the quotient. That's why these numbers are called quotient numbers. That's why the rational number represented by Q. The numbers how? In the form of P by Q, but Q is not equal to 0, and P and Q are co-prime numbers. Co-prime means there is no common factor for two numbers. For example, 4 by 6. 4 by 6 means here we have to reduce. 2 2s are 2 3s are. Like that we have to reduce the rational number. That's why here see that is there any common factor? No common factor. That's why P and Q means the two numbers do not have any common point. Their HCF is 1. Therefore, the rational number represented by Q. Q means what? Quotient numbers. So that's why natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. But the converse is not true. Suppose here I am taking 0. 0 is whole number but not a natural number. And I am taking negative number minus 3. Minus 3 is a integer but not a whole number but not a natural number. And take 2 by 3. 2 by 3 is a rational number. 2 by 3 is a rational number but not a integer, not a whole number, not a natural number but all natural numbers. For example, I am taking 5. 5 means 5 by 1. I am taking 6. 6 by 1. So, every natural number can be written as in the form of p by q. That's why the natural numbers are whole numbers. The whole numbers are integers. The integers are rational numbers. Now, I am going to explain properties of rational number. First, I am taking two numbers. 2 is a natural number, 3 is a natural number. Add both. 2 plus 3 how much? 5 is a natural number. So we can say natural numbers are closure under addition. Next, their product 2 into 3. Multiply both numbers. 2 into 3 how much? 6. 6 also natural number. So you take two natural numbers, their product also a natural number. Therefore, natural numbers are closure under multiplication. Suppose take the difference 2 minus 3. 2 is a natural number, 3 is a natural number. Subtract minus 1. Minus 1 is a natural number, minus 1 is not a natural number. So, therefore, natural numbers are not closure under subtraction. Take 2 divided by 3. Means how to write 2 by 3. 2 by 3 is a natural number, 2 by 3 is not a natural number. Therefore, natural numbers are not closure under division. In the same way, whole numbers are closure under addition and whole numbers are closure under multiplication. What about subtraction? Subtraction also same way. 2 is a whole number, 3 is a whole number because natural numbers are whole numbers. So 2 is a whole number, 3 is a whole number, difference minus 1. Minus 1 does not belong to whole number set. Therefore, whole numbers are not closure under subtraction. Not closure under subtraction because we got a negative number. Negative numbers not in the whole number set. Under division, take 2 is a whole number, 3 is a whole number. The division 2 by 3 is not a whole number. Therefore, because the rational numbers means 2 by 3 in the form of p by q not belongs to whole number set. So, here whole numbers are not closure under division. Now, what about integers? Integers also closure under addition. Okay, closure under multiplication. And what about here getting the negative value? So, consider as 2 is an integer, 3 is an integer. The difference also integer, getting integer. Therefore, so negative numbers are there in the integer side. Therefore, the both are integers. The result also integer. Therefore, integers are closure under subtraction. Integers are closure under subtraction. Now, take 2 is an integer, 3 is an integer. The division how much? 2 by 3. 2 by 3 is in the form of p by q. It is not a integer. Therefore, so integers are not closure under division. Integers are not closure under division. Now, going to explain the rational numbers. Suppose take any two numbers, their sum or product or subtraction or division. These all are rational numbers. See that 5 is a rational, 6 is a rational, minus 1 also rational, 2 by 3 also rational. But if you take 2 by 0, 2 by 0 is not defined. Except this case, in all cases, it is possible. So therefore, under addition, under multiplication, under subtraction, under division, except for 0. Okay. Now that is about the closure property. Next, what is commutative? Commutative means take any two numbers. Suppose I am taking 2 comma 3. Add both 2 plus 3 and 3 plus 2. 2 plus 3 how much? 5. 3 plus 2 how much? 5. Both are equal or not? We can say 2 plus 3 equal to 3 plus 2. So we can say that here natural numbers are commutative under addition. Whole numbers also commutative under addition. Consider as whole number. Okay? 2 is a whole number, 3 is a whole number. 2 plus 3 equal to 3 plus 2. So whole numbers also commutative under addition. Integers also commutative under addition. Rational numbers. So consider the rational number. 2 is a rational number, 3 is a rational number. Okay? 2 plus 3 equal to 3 plus 2. So rational numbers also commutative under addition. And what about multiplication? Take 5 into 6. How much? 30. And 6 into 5 how much? 30. Now 5 into 6 is equal to 6 into 5. So here we can say that natural numbers, whole numbers, integers, rational numbers all are commutative under multiplication. In the same way, associative. What is meant by associative? Associative means take any three numbers. Take any three numbers. So here 2, 3, 5. 2 here. First I am taking under addition. 2 plus 3 plus 5. 2 plus 3 how much? 5 plus 5 equal to 10. Or 2 plus 3 plus 5. That equal to 2 plus 3 plus 5 8. 8 plus 2 10. Now both are equal or not? Both are equal. So we can say 2 plus 3 plus 5 equal to 2 plus 3 plus 5. This is possible for natural numbers, whole numbers, integers and rational numbers. So here natural numbers, whole numbers, integers, rational numbers are what? Associative under addition. Associative under addition. Next, under multiplication. Take under multiplication, take three numbers for associative. No? 2 into 3 into 5. Okay? So, 2 into 3 into 5, 15. How much? 30. And 2 into 3 into 5. 2 into 3, how much? 6. 6 5s are 30. Now, both are equal? Okay, both are equal. Now, this can be written as 2 into 3 into 5 is equal to 2 into 3 into 5. Therefore, natural numbers, whole numbers, integers, rational numbers are associative under multiplication. Okay. Now, what is identity? Identity means what are the identities? 0 and 1. 0 is called additive identity. 1 is the multiplicative identity. Now, I am taking 5. So, I want a same number. What must be added to get the same number? By adding 0. One more example, minus 7. I want to get the same number. What must be added? 0. Here, you take a number by adding 0, getting the same number. Here, 0 is called additive identity. So, in the set of natural numbers, no additive identity. The set of natural numbers, no additive identity. But in the whole number set, 0 is additive identity in the set of whole numbers is there. And integers also there. Rational number set is also there. So the additive identity 0 belongs to whole number set, integer set and rational number set. But additive identity does not belongs to natural number set. And next one, suppose 7. I want to get the same number. To get the same number, what we have to multiply? 1. So by taking a number to getting a same number by multiplying 1, 1 is called multiplicative identity. Why? Because you are multiplying, no? That's why multiplicative identity. So you're adding, no? That's why additive identity. So here, what multiplicative identity belongs to natural number set. Multiplicative identity 1 belongs to whole number set and also integer set and also rational number set also. Next, what is inverse? Inverse means, for example, take any number. For example, 9. I want to get 0. I want to become a 0. What must be added? So, by adding minus 9. And take minus 8 to get 0 means by adding 8. Observe here, the sum always 0. Both are additive inverse of each other. 9 is the additive inverse of minus 9. Minus 9 is the additive inverse of plus 9. And minus 8 is the additive inverse of plus 8. Plus 8 is 8 inverse of minus 8. The sum always 0. Okay. Both are 8 inverse of each other. Simply you can say that, suppose when I ask the 8 inverse of 5 means, just we have to change the symbol. No need to change the number. So that is the additive inverse. Now multiplicate inverse. Suppose I am taking 7. I am taking 7. So here 7 is multiplied with 1 by 7. The product always 1. See here 7 is the multiplicate inverse of 1 by 7. 1 by 7 is the multiplicate inverse of 7. The product always 1. Okay. So what is the multiplicate inverse of 8? Just write the reciprocal of that. 1 by 8. The product always 1. The multiplicative inverse of minus 2 means minus as it is. The reciprocal of 2 is 1 by 2. Their product always minus into minus plus 1. So, this is about the additive inverse and multiplicative inverse.